My name is Bruce Holub from the University of Guelph in Canada. First, I would like to express my gratitude to ISSFAL for being chosen as an ISSFAL Fellow. The organization has been an important part of my career development as a fatty acid research scientist, as well as providing me with many international friendships, which I value to this day. My research career for almost 50 years on omega-3 fatty acids has included basic and applied research, including epidemiological and clinical intervention studies. My early basic research involved elucidating the specific biosynthetic reactions which contributed to the wide discrepancy in omega-3 fatty acid levels between various phospholipids from the same biological source. As a sample of this research, the characteristically high level of DHA in cellular phosphatidylethanolamine was found to be partly due to the preferential utilization of DHA-containing molecular species of the diacylglycerol substrate for their enzymatic de novo synthesis of this phospholipid. In the early years, we gave supplemental EPA plus DHA from cod liver oil, followed by encapsulated omega-3 concentrates in human trials to help elucidate the mechanisms via their accumulation in blood-plated membrane phospholipids that contributed to their anti-aggregatory and anti-thrombotic effects. It was of interest to determine that the rather unique phospholipid species, namely the plasmologenic form of the ethanolamine phospholipid, was the most enriched in EPA following supplementation. In addition to numerous human trials supporting the beneficial effects of omega-3 fatty acids on various risk factors for cardiovascular disease, we utilized the newly developed algal oil enriched in DHA for trials in both vegetarians and non-vegetarian subjects. In addition to reducing triglyceride levels and lowering the resting heart rate, we were rather surprised to find a considerable increase in EPA levels in both serum and platelet phospholipid when DHA, devoid of EPA, was supplemented. These findings indicated the metabolic retroconversion of DHA to EPA in our subjects. In view of Canada's interest in seal oil supplements enriched in DPA omega-3, docosahexaenoic acid, our group has conducted research studies on such in both humans and in rodent models. The experimental studies in mice were in purified DPA, devoid of EPA or DHA, was given orally, resulted in lipid lowering in blood serum and a rather dramatic elevation in EPA levels in both serum and tissue lipids. The overall conversion of DPA to EPA was most pronounced in the kidneys. I've also had the great privilege to collaborate with the late Dr. Eric Dewey and his colleagues from the Public Health Research Unit in Quebec, which resulted in 12 co-authored publications. These major epidemiological studies in the Canadian Inuit and Aboriginal Cree Indian populations found that a higher long-chain omega-3 fatty acid status in the blood serum phospholipid marker, reflecting higher intakes from fish and seafood, was inversely related to cardiovascular disease risk factors and to psychological distress. Further, a higher omega-3 fatty acid status was positively related to gestational age in pregnant women. My direct dietary omega-3 fatty acid analysis on duplicate food collections, we have recently reported that pregnant women and young Canadian children of various age groups fall well short of target DHA intakes as established for optimal development and the health of the very young. At present, we are continuing our collaborative research with nephrologists when the benefits of supplemental EPA plus DHA to renal patients on dialysis have been reported. As well, we are extending our ongoing research on assessing the dietary intakes of omega-3 fatty acids from fish with colleagues from the Great Lakes tribal fisheries. Finally, as an educator, I also try and provide updated information and commentary on new research as published relating to the impact of EPA plus DHA on human health on the website by way of the website address www.dhaomega3.org. Thank you.